Hi everyone, in this video I am going to continue our sample questions, solving our sample questions. Let's look at the question. Beta is 1 milliampere per volt square is given and absolute value of V threshold equals 1 volt are given for the MOS transistors in the figure. Remember, this is nmos and this is nmos transistor, this is pmos transistor, and ID question point 1 is 4.5 milliampere, ID question 2 is 1 milliampere, and V output equals 0 volts are given for V input equals 0 volts for DC operating point. So these are given. Find AC voltage gain of the circuit. For AC, for passing to AC analysis, we should find GM values. What is GM1? 2 times Kn times, and Kn is 1 milliampere per volt square, times ID, which is 4.5 times 10 to the minus 3. And here GM1 equals 3 millisiemens, GM2 equals 2 times minus 3, which is 1.41 millisiemens. Okay, my DC analysis is done, guys. Let's sketch the AC equivalent of this circuit. In AC case, remember, this DC voltage supply will be grounded. Also, this DC voltage supply will be grounded. Here is my VI, and here, okay. Let's sketch the circuit in. Okay, the first circuit is pmos, and it sees ground. Here my VI inputs, and then here there is also VICs 1 mega ohm. Okay, and then here's 110 ohm grounded, and then comes my nmos. Here DC voltage supply will be grounded in AC case. So this is grounded, and here my 4K. So let's find the gain, and the output is here. Okay, the first step of the gain, let's say here is V output 1. Okay, let's write V output 1 over VI. What is this? This is common base. So what was, common emitter. What was common emitter formula? Gm minus Gm RC divided by 1 plus Gm RE. But be careful, there is no RE component. Emitter is grounded, so gain will be minus Gm1 times RC1. So the question is, what is RC1? RC1 is what I see in here. Here I see 110 ohm, and this are emitter 2, and our emitter 2 simply equals 1 over Gm2. So 1 over Gm2 equals 707.213 here. And this is parallel to 110 ohms. So RC1 equals parallel to 110 ohms. So it is equals 95.19 ohm. So V output 1 over Vi equals GM1 was 3 millisiemens, so 3 times 0.09519 equals 0.2855. This is the first step of the gain. Second step of the gain is V output over VO1. Let's look at second step of the gain. So we are right now here, V output 1. So second step of the gain is common base configuration, and simply formula is, remember, common base formula common base gain formula is, it is V output over V emitter GM-RC over 1 plus GM-RB over beta force. But in this configuration there is no RB. Look at the circuits. RB is here grounded for second gain. So second formula simply becomes GM2 times RC2. So V output over V output 1 is GM2 times RC2, and it is equals, I am here, 4K times 1.21 millisiemens. 1.41 times 4. It is 5.64. So my overall gain V output over Vi equals V output over VO1 times VO1 over Vi, and it is 5.64 times 0.2855, and it is equals 1.61. So that's it. This all is asked in the question. Thank you for listening, guys. See you at the next videos. Take care of yourself.